just talking about grammars. In English also you follow grammar, right? If you write a sentence, it should be grammatically correct. A sentence being grammatically correct means there is a way you write English language. Okay, so whenever you are having a language, there is a grammar behind it. Suppose it is an English language, you want to write a sentence. Let us take a simple sentence, if at all it is. We can write it like a sentence can be a sentence will have a noun phrase, as well as a verb. Okay, the dog jumps or something like that. Okay, means what can be this noun phrase? Let me write it separately. A noun phrase can be, it will have, if at all we are talking about a dog, so there will be an article and a noun, then it will be a noun phrase. Then we can have a dog barks or dog runs, whatever. So let me name the articles and noun also. Articles will be either a or an or the. Okay, apart from article we have noun. So what can this noun be? Something, maybe there will be certain ways to define, but however let me keep only two nouns. It can be a boy, it can be a dog. Okay, let us take some verb also. Let me tell you one more thing, that whatever we are writing here, left side, you can see we are writing in this brace and diamond, and some of the things like a and the boy, dog, I haven't written the brace, this thing, or I am writing here some verbs. Let me say run, walks, jumps, etc. So using this rule, this set of rule, this is a particular sentence. If I tell you you have to write a sentence, you should follow this rule, this rule of the grammar. Your sentence will have one noun phrase, along with that it will have verb. In a real grammar you will have several rules, but let us take this particular simple example where we are talking about this scenario, that it will have a noun phrase and a verb. So what are the possible sentences you can make? If this is your language, then in this particular language several different strings are possible. You can have a boy jumps. Okay, you can also have a dog walks. Okay, you can have whatever, a boy runs. Okay, different possible combinations and different possible strings are possible. Okay, so this was the story of your simple English language, where you have considered just one sentence which is of this form. So while learning we will try to have simple grammars, simple set of rules. This can be considered as one rule, and this can be considered 1, 2, 3, 4, 5 rules actually. So this can be considered as set of rules. 1 2 3 4 5 है ना, 5 set of rule, 5 rules in one set. Usually in a grammar you will call it as production rules. Okay. So this was the story of your English language. If you are thinking about your C language also, in C also how you write some statement. Given one statement, you will have, how do you write a if statement? If a statement will have, if is compulsory, if is a keyword. After that you will have certain statement. Okay. If this is correct, then suppose in C you are not writing that, then you are writing like this. Okay. Then certain statement, if at all it is correct, else is a keyword. After that certain statement. Okay. This is the way you write. Now if you are writing this, you should also define what a statement can be, right? So these all the things, if, this brace, else, these can be considered as terminals. Terminals are something which are not replaced, है ना. However, variables are something which are replaced by terminals. Okay. Usually while writing your grammar, what you do, terminals are written in small letters. However, variables are written in capital letter. Now whenever we try to write a formal grammar, we should write in terms of all these four things: variable, set of, I will tell you, V, T, S and P. So what is this V? V is the finite non-empty set of variables. What is it? Finite and non-empty. Set of terminals. Okay. This is also finite and non-empty. This is a starting symbol. Okay, a symbol, let me call it variable. The variable, this variable will also be present in V. So with this variable you will always start. Okay, suppose in your example you have seen a statement, or you have seen sentence, here above we have seen, suppose if a statement. So in your grammar for this if statement there are several variables and terminals you can see. However, if a statement is the starting variable. Okay. Now this is the P for production rules. P is for production rules. This is also finite and non-empty. This is also finite and non-empty. So these are four things that you will keep in your grammar. Now what do you think? Can there be something common between set of variables and set of terminals? Let me ask this question to Prabhat Kumar. Prabhat, do you think there can be something common between the set of variables and set of terminals?
No idea, sir.
You don't have any idea?
Yes, sir.
Okay, no problem. Okay, let me tell you that set of variables and set of terminals will not have anything in common. Set of terminals are something.
Sir,
Okay.
sir, what I think is like terminals consist of signs, right?
Okay.
Some specific symbols. So
Symbols.
how can variables and terminal can have anything common? Because
Yeah.
generally we have variables like A, B, C, like something like that.
Hmm.
But terminals have these specific symbols, so it's
Yeah,
not,
yeah.
I think, possible to have something in common.
Definitely. Terminals and variables will not have anything common. Variables are something which will be used in between your grammar, to which these variables will be in last will be replaced by the terminals. Terminals are something which are actually the part of your alphabet. So this will be the final, this will form the final string. Now a grammar a rule, okay, a grammar rule, if we are writing it like with the start symbol s gives, suppose as, bs and lambda. If I am writing a grammar rule like this, it will mean that there are three rules here. One rule is s gives as, s gives bs, or s gives lambda. These three rules, they can be written in one statement like this as one rule. Okay. So in a grammar, suppose if you have just these three things to say, you can have the set of variables as s, set of terminals as what are the terminals, a and b only, and starting symbol is always s variable, and production p is set of rules which is s gives as. It can be written like this only, or the three separately. If you want to write, you can write it like that. S gives bs and s gives lambda. Okay. So in this way, if you are writing, this is one grammar. So every rule, this thing s gives as, so every production rule, if you are writing it, it will be in the form, okay, if I am writing the structure of a rule, so it will be in the form of x gives y. Okay. And suppose x is element of what can be there in the left hand side and what can be there in the right hand side. We are thinking about this. So if at all it is a grammar, usually there is one thing we call it regular grammar, and there are some, as I will see, few types of grammar. In the last, it will be type 3 grammar, we call it regular grammar. However, other types of grammar are also possible. So on left hand side and in right hand side, what are the things that we can keep? So in left hand side, if I am writing, we can have the variables as well as terminals. Here I want to write something, whether it should be plus or star. X is element of something. I am writing in the left hand side, we can have the variables as well as terminals. Combination of these are also possible. However, at the same time, here I have written plus symbol, which means it cannot be lambda. On the left hand side, we cannot have lambda. We cannot have a rule saying lambda defines something. Okay, this is not possible. So it is plus symbol here, which is saying that you will have V or T or any combination of these. Now, which I am saying that on the left hand side you must have at least one variable, right? Now, if we talk about the right hand side, what will happen? On the right hand side, what is this y? Y includes, on the right hand side anything is possible. You can have any combination of V or T. So, you can write it as V union T, and here it will be a clean closure of V union T. Because of that, it means you can have something is defining, you can have any combination of variables and terminals. You can also have lambda, no problem, this is allowed. So, having known these things about the rule, let me now start the types of grammar basically. So, you will have, first of all, let me tell you, type 0 grammar. Okay. Type 0 grammars are also called as phrase structure grammar. You can also understand type 0 as unrestricted. There is no restriction on it. What does this mean? This means you can have x gives y a rule where there is no restriction what can be on left and what can be on y. Means the restriction that we have just told, that it will have V union T plus, that is the only restriction and no other restriction. Later on in type 1, type 2 you will see some more restrictions are added. Okay. Such regular such type 0 rules will be used for Turing machines, I should say. You have seen these things maybe in your formal automata classes. So, these kind of rules which are unrestricted, they can generate any RE language. RE means recursive enumerable. Recursive, if check here the spelling, I don't know, recursive enumerable language. Okay, this was the story of type 0 grammar. If at all, now we think about type 1 grammar. Type 1 grammar. You also call it context sensitive grammar. Okay, or sometimes just CFG. So, here you have a rule, a restriction which says if you want to write something like x derives y, then the length of x should be less than or equal to length of y. Okay, the length of left hand side cannot be more than the length of right side. Okay, on the right hand side it can be more. Okay, if you are deriving, then something can derive to a larger string, however it cannot be reduced. Okay, so it can, because of that, it can be also called as non contracting. Okay, non contracting grammars. Suppose you want to have s gives lambda, this is allowed. S gives a, s, b, this is allowed. However, something like a, s, b gives something, a smaller thing, a, it is not allowed. However, let me repeat, lambda is allowed. S gives lambda. Here you can see it is shortening, but this is allowed. This kind of language, as I told, type 0 grammar was used in Turing machine. This type of language can be used in your LBA. Okay, it can be used in your linear bounded automata. Linear bounded automata. Till now, if you have any confusion, if you want to ask something, please interrupt. After that, you will have, we can call it type 2 grammar. Type 2 grammar. So what happens in type 2 grammar? It will be called as context free grammar. Context free grammar. CFG. And there are certain rules. First rule is it will satisfy the rules of type 1. In blue, satisfy the rules of type 1, and then if you have something like x gives y, then x should always be a variable only. Okay, it cannot be a terminal. So on the left hand side you will have a single variable. Let me write it especially, that left hand side, I believe LHS you will understand, should be a single variable. What about the right hand side? Right hand side is free. Okay, RHS is free. There is no problem. We have only restriction for the left hand side, that right, and the left hand side you will have single variable only. This was the story of type 2 grammar. This is context free grammar. You will be using such grammars for your push down automata. Let me write it. Push down automata. Okay, such are the things you have been seeing. Now we are coming for type 3 grammar. The type 3 grammars will also called as regular grammar. Type 3 grammar. you will call them as regular grammar. So here you have certain more restrictions. Let me confirm your okay, am I audible?
Yes,
Yes,
sir.
sir.
Okay, very good. So here I am telling you about type 3 grammar. It is a regular grammar, and some restrictions can be something like if you have a rule x gives y, then x will definitely be single variable, no problem. However, we have restrictions on y also. Y can be either stream of terminals. Other possibility is a stream of terminal followed by a variable, or a variable followed by a stream of terminals. Any one of these three. Okay, any one of these three, not the combination of them. Okay, combination, we can think about the combination also. That is also a possibility in different rules. But if you want to make it a regular grammar, so it can be either, I should say, right linear or left linear, not the both. Okay, if at all it is becoming both of them, or both the rules are coming, in that case it will be not regular, it will be something else. Sometimes you will find later on that it is in between type 2 and type 3, but you can consider it as type 2. Okay, if you want to keep it in a type 3, then it should be either of these, either this one or this one. Okay, this is always allowed, no problem. For example, let me tell you, if you are keeping something like okay, this is example, S gives AA and this A gives B. Okay, two productions, two rules I am showing you here. What is this? Can you consider that it as what it is? Your variable is on right side, so you will call it as right linear. Okay, this is right linear. So in right linear, so what I am telling you is this rule and this rule, both of the rule are right linear. So this will be a regular grammar. Another example, if I am telling you S gives AA or A gives B. So this will be left linear. Okay. Now if you have certain grammar which is S gives AA and A gives BB, so one of the rule is saying it is left linear, another rule is having a right linear rule. In that case, this set of rule makes the grammar non-regular. Okay, so the grammar having such rules, a combination of left and right both, will not remain regular grammar. To remain regular, it should be either right linear or left linear. All the rules should be left linear or all the rules should be right linear. The combination of these two will make it a linear grammar. Okay, a linear grammar. You might have heard or you may see later. So every regular grammar is either right linear or left linear, not the both. This was the story of your grammars. Now something, if okay, till now, if you have to ask something from these types, tell me. Do you want to ask something, or you have understood all the things? If you have understood, I will ask questions. Then you cannot say that you don't know. Please go ahead. Do you want to ask something? You don't want to ask anything. Let me.
Hello,
Yeah, go ahead.
sir. If there is a combination of left linear and right linear, so whether it is considered in regular grammar or not?
No,
Okay, why, sir?
because
Why
this
it
is the
happens?
rule. This is the rule, na? Otherwise, it will be type 2 grammar.
Okay, sir. Okay.
Okay, I am writing this. So now you have to tell me, this is a grammar. This grammar, what is the type of this grammar? Okay, I have to name, है ना? Let me ask this question to Rishabh Kumar. Rishabh Kumar, tell me, what is the type of this grammar among type 0, type 1, type 2, type 3, highest possible type? Rishabh Kumar.
Yes, sir. Sir, in LHS there is a single variable.
Very good.
No, there is multiple variable like A and B. And A gives sir AB and A. So there is one variable. So we can say that it is type 2.
Okay. Can it be type 3?
No, sir. One is no, sir. It can't be type 3 because when S gives like BA and AA,
Okay.
left linear and right linear both.
Okay.
But
Okay.
in when A gives B, then it is the like right linear because it is right hand side. So it is a combination. So can't be the type 3.
So it is a type 2 grammar.
Yes.
Okay. Now one more example. Let me take it. S gives AS, BA, and AA, and your AA gives AB or A. This is a grammar. Now tell me. Let me ask to Pradeep Khanna. Pradeep,
Yes, sir.
you have to tell me what is the type of this grammar.
Sir, I think it will be a type 3 grammar.
Pradeep Khanna thinks it can be a type 3 grammar. Anybody has any problem in this?
Yes, sir.
Yes, sir.
You have problem. So tell me, what is the problem?
Sir, here there exists a right linear and left linear.
Okay, right linear and left linear both. So what should be the type of this grammar?
Sir, it will not be type 2, then I think it will be type 1, sir.
Type 1.
Yes, sir.
So Vivek is saying it can be type 1.
Yes, sir. It
Now,
cannot be type 2, sir.
it cannot be type 2. Okay, type
Yes, sir.
2 it cannot be. Type 3 it cannot be then.
Yes, sir.
Okay, so it can be type 1 you are saying. Okay, let me make it. How can I? Hmm. So now we will check type 3, type 2, type 1. Let me write type 0 also, then we will see type 0 also. So which one it is? Anybody else? Are you satisfied? Type 1, or it can be type 2, type 3, type 0, anything else? Or let us finalize it is type 1.
It will be type 0.
Who is saying?
Satyavrat.
Okay, Satyavrat. So you want to say it is type 0, it is not type
Yes,
1.
sir.
Why?
Yes, sir. Because of the production, AA gives A. Here, the length of RHS is greater than length of LHS.
Okay. The, the length of left hand side is more than the length of right hand side.
Exactly, sir.
Okay, yeah. In type 1 grammar, we have seen that there is one restriction which says that it is a non-contracting grammar. The length of left hand side should be less than or equal to the length of right hand side. In that case, definitely it will not be a type 1 grammar. Let us check whether it is type 0 grammar or not. So type 0 says there is no restriction, so definitely it is a type 0 grammar, no problem. So it is not a type 3 grammar, not a type 2 grammar, not a type 1 grammar, it is a type 0 grammar. So having known these things,
Yes, sir.
you want to say something?
Yes. Sir, if type 0 has no restrictions, then type 1, type 2, type 3 can also be type 0.
Yes, definitely. Whenever we have a type 1 grammar, it has to be a type 0 grammar along with some certain restriction. Whenever we have a type 2 grammar, it means it has to follow all the rules of type 1 grammar, and after that some more restrictions. That means for being a type 2 grammar, the length of the left hand side is always less than the length of the right hand side. However, we have seen that for type 2 grammar there is a restriction that on the left hand side it should be a single variable. In that case, it has always to follow that rules of type 1 grammar. So similarly, whenever it is a type 3 grammar, it has to be type 2 grammar as well, where it means you will have one single variable on left hand side. So whenever the question is asked for you to tell the type of this grammar, whether it is type 0, type 1, type 2 or type 3, in that case it is actually asked which is the highest possible type for this particular grammar. So you have to try to find the highest possible type of that particular grammar. However, if you want to play with words, definitely you can play, if at all marks are not associated, you can play with words that if it was said that which type of grammar it is. So since type 2 grammar is also a type 0 grammar, so I have answered that it is type 0 grammar. So you can play with words, that is also a possibility. However, whenever there is marks associated with it, you should not play with words, you should give the highest possible type of the particular grammar. Now if we talk about derivation kind of thing, suppose you have a production x gives y, you have this production. Suppose you have something uxv, so you can reach to uyv easily. How? By deriving x. In place of x you can substitute y and you get uyv. So what happened actually, this was your word, let me say word 1, you reached to word 2 by substituting your x with y. In the place of x you kept, you have seen the production rule, and from this particular rule you have noticed that x can be derived using y. So in place of x you have kept y, and so from word 1 you have got word 2, no problem. So let me write it, you have got word 1 to word 2. Okay. Now suppose this, in this way you have derived, in place of y some new things can be kept, in place of those new things some new things can be kept, and in last you will have only the terminals, there will no variables. Suppose you started with 1, word 2, you got word 3, and so on to word n. Okay. You can write it as you have got to word 1 to, let me put it a star here, to word n. Okay. This is a possible way to represent derivation of word 1 to word n. Okay. Now if you think about a language of a particular grammar, let me write it as language of this particular grammar. Language of grammar will be those words element of your terminal star, okay, for which, those words for which if you start from your start symbol you can reach to this word, particular word, after derivation using the particular grammar. Using the particular grammar by replacing s with something and those symbols with something, you can reach to w, then such w are part of this particular language. Okay. So derivation of w, as you can see, you will start with, okay, let me write it, you will start with s. With s you will get something like w1, you will replace some of the variables here, maybe one by one variable here, you will get one w2, you will replace another variable here, you will get w3, you will replace another variable, and so on. In the last you will get w. So if you are if there is a possibility that you started from s, starting variable, and somehow by replacing you are getting this word w, then this w is a part of your language L. Okay. So you can say w is part of language of this grammar G. Okay. And this thing, what happens, s, you have reached w from s, you can call it as derivation of w. Derivation of w. Okay. This particular thing you have got w here, let me make it in black. This w, this is the final thing that you have got, you can call it as sentence. However, all of these including the final one, all of these W3, W2 and W1, even the start symbol S, all of the in between words, they will be called as sentential forms. Okay. So now what a compiler does, compiler actually attempts to create the sentence, okay, using the production rules. You will have certain production rules, you will use those production rules and try to form this sentence. In between some sentential forms will come, no problem. The attempt is, the finally what you want to derive W starting from the start variable. You will start from the start variable, you will replace with certain whatever desired, and then finally you will try to get the sentence. If using the set of rules, using the grammar, you are able to you are able to derive W, then this W is accepted, this sentence is accepted by your compiler, otherwise it is not. So while derivation, what you do, you try to create derivation tree. Okay. Suppose you have to derive from S, certain rules should be there. Some example, if I am taking, okay, let be, you have started with S, some variables, if at all you were having S gives AB a rule, so you can replace S with A as well as B, these are two variables. Now if there is a rule A gives AA, so this A can give you A as well A. You also have A gives lambda, so this A can give lambda here. For B also you might be having BB, so it will give you BB, and then B can be giving lambda, so B is giving you lambda. In this way a derivation tree is made. Okay. Now if this particular set of rules are same, this set of rules are not changing, then here what you have derived is, you have derived A lambda, B lambda, so you have derived AB out of S. Okay. So this AB is accepted by your compiler using this derivation tree. Now for this AB, as long as these rules are not changing, you will always get the same derivation tree. If these rules are changing, then only this derivation tree may change. Okay. Sometimes these rules are not defined nicely. In that case also you may get a different derivation tree for the same sentence. Those grammars will be called as ambiguous grammars. Okay. Those grammars will be called as ambiguous grammars. I will tell you one example of ambiguous grammar. Maybe I will write here and I will tell you in the next class. S gives S plus S, S star S, A, B, C. Okay. This is a simple grammar. Looks like nice. However, if you want to derive something like A plus B star C, then you may get two derivation trees. So try it yourself whether you get two derivation trees for this expression or not. For now, today we have completed. We will see next about this, the derivation we can see in the next class, and then we can move further for understanding more on compilers.